Don't.
You will be Alright, now please pay attention. We're about to finish. There is one more question.
GB.
When we were doing geometric progressions, and let me just give you a quick rundown to what I'm interested in. Let me say I take a sequence that the first term is 3, and I multiply it by 2, which means our ratio is equal to 2, right? 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24, 24 times 2 is 48, 48 times 2 is 96, and so on and so on. This would be a geometric progression where the common ratio is obviously going to be greater than 1. This type of sequence diverges. It becomes bigger and bigger and bigger and bigger up to infinity. Are you with me? Well, you can use your formula for your GP here in order for you to find whatever question answer. But if I take a sequence like 24, that's the first term, and we find half of 24, half of that, 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 half of that. 24 divided by 2. Here the common ratio is 12 upon 24, which is a half. Common ratio, by the way, can also be a negative fraction. This sequence, the thing with a negative ratio, sometimes one term is positive, one is negative. But I'm not looking at when it's a ratio. When the ratio so is a fraction. This sequence converges. Converging sequence, because it becomes smaller and smaller and smaller, it tends to, that's how we mean, a limit. It gets closer and closer and closer to a certain number. Once you keep on dividing by 2, this gets closer and closer and closer to a number. How do we find that number? We find that number by using sum to infinity. So, sum to infinity is applicable on converging series. Adding all of this, you get closer to a certain number. You understand that? Now, the way you solve this, if you were asked what is the sum to infinity, if you keep on adding these terms together, to what do they get closer? To what limit? To what number? That one is infinite. There's no sum to infinity for diverging series. But this one gets smaller and smaller to some value, and we use that formula. So we have got sum to infinity where a is the first term, 24, and 1 minus r being a half. You can calculate that. So this is going to be 24 divided by 1 minus a half is a half. 24 times 2 is 48. Once you are adding all of these parts, you're going to get to 48. A number that is closer and closer to 48. 24 plus 12 plus 6. You are adding smaller, smaller, and smaller, and smaller, and much smaller, much smaller, much smaller. It tends to 48. It gets closer and closer to 48. In this case, your common ratio would be between -1 and 1. It would be a fraction. When the ratio is greater than -1, right? Like -0.5. You follow what I'm saying? Or when it's like in this particular case, what I was using, the ratio is a half. And that part is important, because that is where this question is now focusing on. In your textbook, I think somewhere in page 60 somewhere, page 66, 65, you will have the work that we did on converging series. Now, we're going to use this particular concept if we solve this question. Okay? So first things first, let's hear what the question is saying. Now that you are quickly rearmed and that you know what we're referring to. So, this question says, the first two terms of a GP are 1. So the first term is 1. The second term is a horrible number. It's 1/3 times square x. And they say where x is a number between pi upon 2 and 0. Let's just, while we're here, calculate what is our radius. Our radius, my goodness gracious, our ratio. Second term divided by first term. Second term is 1/3, 10 square x divided by 1. Anything divided by 1 is just equal to that. So that's our R. Now the question says, find the set here. We are looking, our answer is a range, so it's probably going to get an inequality. We're going to get an inequality. The set of what? Of values of x for which the progression converges. The moment it tells you that it converges, this is what we're going to have to deal with. We're going to take this here, which is our ratio, and we're going to sub for our ratio for 1/3, 10 square x is less than 1, greater than -1. Are you with me? Where this part is this part. This is our ratio. We calculated it as our what? As our ratio. Now, I told you it's a range. Our answer will be inequality because we use this 5 to say off. That means it's not a definite answer. The way you solve any inequality, for example, if you have 3x less than, let's suppose, 5. Let me even add something. 3x plus 1 or minus 1, let's say, is less than 5 and greater than, let's say, 4. Or, for that reason, let's say 2. The way you'll be solving such an inequality in algebra, one of the ways you can do that is you are going to add 1 to both sides. Are you with me? So you have 3 less than 3x less than 5. 3 greater than 9. Then you go and you say, let me divide both sides by 3, for example. Therefore, x is going to be a number less than 2 and x is going to be greater than 1. That's how you'll be solving inequalities. We're going to use the same concept. But I'm going to first multiply by 3. And then I'm going to take the square root so that I can have my 10x to be on my x. Hello. You follow? So first things first, multiply by 3, by 3, by 3. It's -3 less than 10 square x less than 3. Now we need to get the inverse of anything squared is the square root. Square root here, but the moment you take square root here, we're going to reject this because the square root taken now does not exist. You with me? This is going to leave you with that, which is the square root of 3. Therefore, this part is not considered. So we can answer the question. 10x less than square root 3. X therefore is inverse tangent. Make sure you calculate this in gradient mode, please. Of root 3. Not equal to but less than. Give me the answer. Therefore, x is less than what? 5/3. Pi over 3. Part B of the same question. Are you following? Are you following? Find the exact value. Maybe I should write that question down, okay?
Exact.
And underline the word exact
Exactly.
of the sum to infinity. Is it not so? Of the sum to infinity. When x is equal to pi over 6, pi over 6. Do we know what is our formula for sum to infinity? Good. So I want you to, let's first show you how you do that. So our formula is a 1 minus r. This is the formula of sum to infinity. Our answer here, our a was, drum roll, 1. Our r was, drum roll. Are you with me? Oh, you are sleeping. What is that? 1/3 10 squares. But they are saying x is equal to pi upon 6, so we're going to substitute that value in there. So can I take it off? Because I don't want to rewrite. Okay. Now let me show you how you put this on your calculator. Okay? Put this on your calculator. Press 1 on the calculator. Then you press 1 minus 1/3. Open a bracket on your calculator. I need you to press this. Button. Are you with me? Okay. Did you press that button? You did now. And it's going to go something like that, yes? This little part here, and I want to explain the concept what we're doing. 10 square x is the same as 10x times 10x. So I want you to put 10 of this stuff, right? So you're going to put in your calculator, you're going to put 10 pi over 6, right? Then you close the bracket and then you're going to still have that little thing there. You get it? And up there, you put a little square. Yes. And press equal to. Going once, going twice, going 3 times, going 4 times, going 5 times. AS level students, HPS 2020. Going once, going twice, going 3 times. The final answer should be 9/8. If not, go back, check again. Anybody will calculate?
These are the calculators.
Our resident Ivory Coast guy, full of ivory in his mouth, got it. So we can also, hello, come so we can look at the focus. Is the focus okay?
It's
can
on, yeah, they can see it.
What can they see?
Yeah, they can see
They can see
the
it. I can see it. I sure can see it. All right, quick talk.
Yeah.
Here's my time. Stop the tape. See on the board.